do in this video is I'm going to give you a quick review of the formulas that you need to know for this chapter. So uniform circular motion. So we're dealing with objects that are moving in a circle. Now, keyword uniform. These are objects that are moving at constant speed. So let's say if the object is going in the counterclockwise direction, the velocity vector is going to be upward at this point, and there's going to be an acceleration vector known as centripetal acceleration that always points towards the center of the circle. So when the object is here, the velocity vector will be directed west, but the centripetal acceleration will always be directed towards the center of the circle. Now, the centripetal acceleration is equal to the square of the velocity divided by the radius of the circle. So as you double the velocity, 2 squared is 4, the centripetal acceleration increases by a factor of 4. Now, keep this in mind. The object is moving in a circle at constant speed, but because it's changing direction, the velocity changes. And whenever the velocity changes, there's going to be an acceleration, because acceleration is the change in velocity divided by the change in time. Remember, velocity is speed with direction. The magnitude of velocity is constant for uniform circular motion, but the direction changes. And so because the direction is changing, the velocity is changing, which means that there is an acceleration. So anytime you have any object that moves in a circle, you're always going to have some kind of centripetal acceleration. Now, according to Newton's second law, the net force acting on an object is equal to the mass times the acceleration. So anytime you have an object moving in a circle, there's going to be something called a centripetal force, and it's equal to the mass times the centripetal acceleration. So replacing AC with v squared over r, we get the formula for the centripetal force, which is mv squared over r. So make sure you add these two formulas to your list. And you could also put this one as well. Okay, let's just redraw this picture real quick. Now, going back to this equation, let's talk about how we can calculate the velocity for an object moving in uniform circular motion. Now, we know that velocity is displacement over time, and the distance that the object travels in a circle is going to be the circumference of that circle, and the circumference is 2 pi times the radius. The time it takes for the object to make one complete revolution around a circle, that is known as the period, which is capital T. Both lowercase t and capital T, they're measured in units of time, like seconds, minutes, or hours. The frequency is 1 over the period. Now, if we were to take this equation and plug it in for v, we will get that the centripetal acceleration is 4 pi squared times r over t squared. So that's how you can calculate. You could use this formula to calculate the centripetal acceleration if you know the radius of the circle and the period of the object in circular motion. If you know the period, you can also calculate the velocity using this formula. Now, the period is equal to the time divided by the number of cycles. So for instance, let's say if it takes 30 seconds for this object to make 5 revolutions, the period would be 30 seconds divided by those